Chapter 5, Section 1, Question 1. We're going to identify polynomials and the parts of polynomials. From earlier, we learned that this is a term and we can find the degree of the term by adding together the exponents. So 2 plus 3 would give you a degree of 5 for this little piece here. And then the invisible 1 here plus 5 would give us a degree of 6. Since there's two portions to this, called two terms, this is a binomial. Monomial meaning one term, binomial meaning two terms, and trinomial meaning 3 terms. And what you would have if you went past that is you would have a polynomial, poly meaning many. So a binomial has 2 terms, and we circle this one. But wait, there's more. We are going to write this in descending order. Descending meaning coming down, ascending meaning going up. So descending order, we're going to write this one first, and this one second. Notice that I kept the symbols in front. Here, the negative is here as a minus sign, but this positive goes invisible. The degree, now I have a degree of 5 and a degree of 6, but the degree of the entire thing is going to be 6, because 6 is larger than 5. The leading coefficient is the number in front of everything, 5. Now, many students will pick -3 because that was in the front, but we have to write it in descending order first before we can find our leading coefficient. Chapter 5, Section 1, Question 2. Finding the perimeter of a figure. From previous math classes, I hope you know that the perimeter is we're going to add up all the sides of a figure. So, to find the perimeter of this figure, some people will write this as 4x squared minus 3x plus 5 plus, I'm taking them in any order, 2x squared minus 4x plus 7 plus 6x squared minus 2. With parentheses, without parentheses, combine like terms from previous math classes. 4x squared minus 3x plus 5 plus 2x squared minus 4x plus 7 plus 6x squared minus 2. We're going to combine like terms in descending order by degree. So the first thing we're going to look at are the x squared terms. Notice that I am underlining the symbol in front. That's a positive 4 and a positive 2 for 6x squared. Plus 6 gives us 12x squared. Now these are the x terms, and this is an x term, and this one didn't have an x term. So these two go together and get me minus 7x. And then that is a plain number. That is a plain number, and that is a plain number. So 5 plus 7 is 12. Minus 2 gives me 10. But wait, there's more. You also have to label it. Notice this has parentheses around it and then the label. Many students will label this. But I have met one teacher who said, you labeled the 10, but what about the rest of it? And that is why you will often see that the label goes for the entire trinomial. Another way that you could solve this problem is to stack them and combine like terms that way. So here I would have my 4x squared minus 3x plus 5. Then my 2x squared minus 4x plus 7. And then my 6x squared would go in the x squared column, and my minus 2 would go in the plain old numbers column. If it makes you feel better, you may put a plus 0x to hold the spot. Our handy dandy vinculum, and we are going to add these all together. That is 12 minus 2 is 10. I do have to put a positive there because I know I'm going to have another term here for minus 7x and another term here for 12x squared. And same as before, I could just label it meters, but since I have parentheses here, I might need to have parentheses around that. As your loving yet evil math teachers, we will change this from meters to centimeters to inches to feet to miles. Oh my gosh. So please keep in touch with what that says, so you get full credit. Chapter 5, Section 1, Question 3. We're going to plug into function notation. So, from Chapter 3, you'll remember our function notation, and we could plug in these polynomials, but what I have found is that many students struggle when we do that. So, I'm going to suggest that we start off plugging into the R function first, the C function second, and the P function third. So P of X, P stands for profit, R of X, R stands for revenue, and C of X, C stands for cost. This is an actual formula. So what we're going to do is start off with R. Many students start with R of X because they see R of X. However, X is now equal to 100. So this now has to say R of 100. Many students will plug in on this side, but will forget to plug it in on the other side. So hey, we're plugging in 100. And we're plugging in 100. Hey, look at all those parentheses. This parentheses is not required. This one though, because of the squared, that is a really good idea, but frankly, that one's not required yet here either. But sometimes it is, because if that 100 was a negative, which would not make sense in this particular problem, you would have to have the parentheses. So when in doubt, plug in using parentheses, and you'll be safe. All right, here, this one does have to have the parentheses. We're going to keep the question on the left-hand side, 100 times 100. Many students get this wrong. When you have this, when you're multiplying by things with zeros at the end, this one has 1 times 1 is 1. And you'll have 2 zeros from the first 100, and you'll have 2 zeros from the second 100. 1, 2, 3, comma, hey, that is 10,000. Many students will only get 1,000. Minus 100, and here we can drop those parentheses. And we will get that the revenue for selling 100 items will be 10,000 minus 100. This is another place that people will make mistakes, is they'll give me 9,000. But 10,000 minus 100 gives you 9,900. Next thing we're going to do, so maybe I'll put a little squiggly line here to make sure we don't get confused. The next thing we're going to do is C, again of 100, not C of X anymore. And that is 300 minus 2 times, plug it in, 100. If you did not use parentheses, you'd have to use a star. And C of 100 equals 300 minus 200. Because multiplication goes before addition and subtraction from our order of operations in chapter 1. 300 minus 200 gives me 100. Last but not least, we're going to come up here and we're going to have P of 100 is equal to R of 100 minus C of 100. But wait, we already know that R of 100 is equal to 9,900. And C of 100 is 100. Now be careful, every now and then, this C number goes negative. And so if you have a negative, you'd have a negative and then a negative, which would make a positive, and you'd have to add those together. So be careful about the symbols on your numbers. And so here we have 9,800, which will cause us to have $9,800 in the event that we were to sell 100 of our items. Chapter 5, Section 1, Question 4. Now, this is on a no calculator section. So I'm going to show you how to do it without the calculator. I'm also going to talk to you about how to do it with the calculator. So the first thing is it says circle the graph of that equation. And the window is this. Now, a lot of students have never seen this notation before because it's secretly from the college class. What this is it tells us about the x's and the y's, kind of like domain and range. So this says that it goes from -5 on the x to +5, and that tells me that each of these is counting by ones. The y's go from -13 to +13. And that tells me that each of these is going by ones. And so even if this graph had no numbers on it, we could still use it to determine the scale on the graph. Now, I can read that that's a 0, and that's a 5, and that's 10. So we're still in 099. We're not in 121 yet, but you will see this kind of notation again. And there are some places that will actually write it as -5, 5, -13, 13, just to confuse you, but that is not common, so that's why we're writing it this way. That's what you will see usually in your 121 class. So, circle the graph of this expression, or this equation. So, if you think about, back in chapter 3, we made t-tables for x and y. And we want to think about what's the easiest number to plug in. Some students say the easiest number to plug in is 1, but I disagree. I think the easiest number to plug in is 0, because 0 squared is 0, plus 0 is still 0, minus 12 is minus 12. And from our t-table, that makes an ordered pair of 0, negative, or 0, 12. So if we go to, negative 12, I was right. 0, negative 12, that is on this graph, and if we go to 0, negative 12, it is not on that graph. That's the correct answer. I guess I could have circled the A, but it does say circle the graph, so I circled the graph. All right, I think either one of those I would count as correct. Identifying which is the correct one. Now let's say that you were on an ACT and SAT and AccuPlacer and they gave you the same question. From chapter 3 we learned about graphing on the graphing calculator. Y equals, I'm going to clear out what I have here. I'm going to type in x. We have a squared button, or you can use up in the corner is a 2 using the caret button. So x squared plus x minus 12. Remember, you can't use negative 12 because it'll mess it up. Then we can hit the graph button and it'll graph it. Now, my calculator was used for something else, so it's not centered. To recenter it, I would hit zoom and 6, and it would bring it to where this is negative 10 to positive 10, negative 10 to positive 10, which is not the window that they asked for here. So to change the window, I'm going to hit the window button, which is right here next to y equals, and it says x minimum. We'll change it to negative 5, enter. X maximum is 5, enter. The scale is by ones because each time we're counting by ones. Then, the y minimum is negative 13, enter. Maximum is positive 13, enter. And again, our y scale is going to be by ones. And if I hit graph, I will see this picture. Now, the reason they don't look exactly the same is because this is so wide compared to this. Here, look how small these little ones are, and look how far apart these ones are, and that's why it's such a wide graph. But we can still see that it's the same graph. And if you're not sure, we also have table from chapter 3, second and table, and it gives us some ordered pairs, and we can scroll until we can see the numbers from negative 5 to 5, somewhere around there, and we can look and it'll give us the ordered pairs of these dots. Chapter 5, section 1, question 5. This problem is very important because you're going to see it pretty much in your college classes, in your 121 class, possibly your trigonometry, definitely your pre-calculus, and absolutely in your calculus class. What we're using is from chapter 3, we're using the difference quotient, which is also known as a derivative, or it's to find the derivative. And this is actually the slope formula. The reason it's the slope formula, from back in chapter 3, slope was y2 minus y1 over x2 minus x1. If I were to have a strange graph, I could take a portion of it where this is my x1 and this is my x2 and this would be my y1 and this would be my y2, and I could find the slope, and as long as they're close together, it does look like a line. So here, instead of x and x1 and x2, we are using a and a plus h, meaning a plus a little bit. So these become f of a and f of a plus h. So our slope is now f of a plus h minus f of a all over a plus h minus a. The a's will cancel out, which is how we're getting this formula here. You don't have to know how we got the formula, we just have to be able to use it. But this is to prepare you for the fact that later on, this will give you the slope. Now, we're going to find the slope for this function. Back in chapter 3, all we had to do was find the slope of the line, and we were basically done. Here, we have this formula. Step 0 from back in chapter 3, first I want to take the f of x and make it into f of a. All the x's become a's, so all the x's become a's. Yay! All the x's become a plus h, so all the x's become a plus h. This is a wonderful way to start off this problem because it tells you what these are. But they do want you to find that formula by plugging into that formula, so we're going to plug into that formula, meaning the a plus h version comes first because the formula is f of a plus h minus f of a all over h. As h drops to 0 is the formula to find the derivative, to find the slope at one point. So f of a plus h first minus f of a all over h. That is plugging in, and that alone will give you the answer, but we need to simplify it. So plugging in with parentheses and brackets is the first step. Then we're going to multiply to get rid of the parentheses and back brackets. You may have known that a plus h squared from back in chapter 1 means we have a plus h times a plus h. And what we're going to do is we're going to FOIL this out. Many students have learned FOIL. That stands for first. We're going to multiply the first things together and get a squared. Outside things, we multiply the things on the outside. Alphabetical order, a first, h second. Inside things, alphabetical order, a first, h second. It lets us see that these are like terms that we can combine. And L for last. H times h gives me h squared. Anytime that we FOIL, we can almost always combine like terms here in the middle. And we get a squared plus 2ah plus h squared. We're going to have to do this multiplication every single time we do this problem. Some students actually memorize it, and some students eventually can do this part in their head. So a plus h squared, we have a squared plus 2ah plus h squared minus 32. We're going to distribute the negative. It's going to be a negative a squared. Negative and negative makes it positive 32. We have to keep this over h because, especially to prepare us for chapter 6, we don't want to have the amazing disappearing, reappearing denominator. We have to keep that on there. Then, we're going to combine like terms. Anything that doesn't have an h should cancel. That is a good thing to know. This a squared and that a squared will cancel. If it helps you, you can cross them out, but please cross them out in a way that your teacher can still see that you wrote them there in the first place. This does not have a buddy. That doesn't cancel, but wait, it has an h. It's not supposed to. That has an h squared. It doesn't have a negative version, but wait, it has an h. It shouldn't cancel. This is a minus 32 and a positive 32. It doesn't have an h, so therefore, it has to cancel. We have to rewrite what's left. A lot of students want to go on to the next step and save some writing. Don't do it. This step is one that a lot of students try and skip over because they try and mush it together here. Part of what we're trying to do here in this algebra class is make sure you know how to plug into a formula, how to multiply, and what the difference is between multiplying and reducing, which is dividing, and adding and subtracting. So here, You could just write the answer, but I want to show you two ways of thinking about how to get to the answer. One way of thinking about it is you could make it into 2a over h, make it into two separate fractions, and h squared over h. Extend the vinculum, and reduce, and reduce. And you would get the answer 2a plus h. But wait, there's another way. We're going to be learning in this chapter about factoring. So you should have learned about factoring in a previous math class, but we're going to go further with it. Both of these have an h, so we can factor out the h and get 2a plus h. And if you were to use the distributive property, it would come back again over h. Since it's all being multiplied, this h on top and this h on the bottom will cancel out, leaving us with 2a plus h. This method here is going to prepare you for chapter 6. This method here is going to prepare you for chapter 5, section 3, question 1. This method here is what they're looking for in the college class. So you might want to do it that way. In this class, you don't have to show either of that work if you want to go straight here. I've seen some students who have tried canceling out the h's here and going straight to the answer, and in my class at least, you'll lose a half credit for not having that step, because these are the 1, 2, 3, 4 steps. This is optional, but it really helps to make sure that you plug them in correctly.